Looks like we're live. So are there any new faces that weren't in the last one? This is important. Any new faces? Okay, thank you, and thanks for, didn't mean to put you on the spot. I just, there's some significant overlap, so I want to share some of the same stories. But since just a few of you, I'll modify the stories a little bit. You guys know about my spare tire scenario, and you know about the fuel line on the wife's car, so I'll leave those out of it. So anyway, for those that are new, I'm Jeromy Risner. I actually live just down the road a little bit in Rome, Georgia, but grew up down the road in Anderson, South Carolina. So this is home for me. My background is maintenance and reliability, turning wrenches, implementing maintenance programs, and that led to, as you can imagine, a need to leverage the right software to get the right success, right? So that kind of led into this kind of pre-sales world with software and marrying maintenance practices. So that's me, that's where I come from and why I'm in software now. That's me. The solution is Verison, so that's who I work for and been here as well. And it is a, I worded it perfectly last time. It's an AI-first software solution, specifically designed to handle the unique challenges of MRO inventory. Okay, so that's a mouthful, but the important thing is that the MRO inventory part and the AI-first approach. Okay. So what we do is we provide the solution that you're seeing in the middle here, but with a routine extraction and ingestion of your EAM data. So we're not competing with EAM at all. We do nothing transactional, but we rely on your transactional data from EAM. So we are a partner, maybe that's clear. And, but our AI models will then process this data and give several key business outcomes. And the first of which, again, for a lot of you, this is repeat, so I'll try to keep it brief. The first of which is to understand where you're at risk and you need to increase stock to mitigate risk to production and uptime and all of that. The other immediate benefit is where do we have surplus where we can safely reduce and free up working capital. So to do that, kind of the foundational element is to understand criticality. And that is a very unique challenge. I say that, well, I'm sorry, let me draw a little more clarification between the differences, then I'll tell you why I pause on criticality. So again, transactional, yeah. So your primary records, your material masters, your asset records, your work orders, your suppliers, and your purchase orders, all of that, resides where it does today. We don't change that. We run shotgun, or co-pilot, whatever you want to call it, to EAM to give these various business outcomes, one of which is criticality, which is what we're here to really focus on, but we're focusing on it as a fundamental, as a foundational element to optimization. Let's see, so with that in mind, let's say, so what is criticality? And it's hard to say what is criticality without using the word critical, but it's understanding what is important to operations with some caveats. There's environmental health and safety, there are pure maintenance costs, even if it has very little disruption to maintenance. Some things are critical simply because if it fails, it's a very, very, very expensive repair. There are a lot of considerations when we think about criticality. And there are a couple of different lenses that we need to look at, that we need to approach it with. So that's what we're going to talk about. So let's see. Here we go. It's a measure of how essential an item is to the functioning of equipment or processes. We'll keep it really tight right there. And then, so why criticality? Now, for those who were in the last one, you probably know what comes up next. So why criticality? Now, EAM has an ABC field. Are any of you, and I know not all of you are EAM users, some of you are partners and other things as well, but are any of you leveraging that ABC field? Very good. Okay. Okay, good deal. And am I right in saying that it's a combination of price and turns, our movement? Okay, very good. So the systems I've used over the years, it was the same, and that's why I just wanted to seek validation, confirmation. It was the same, which gives us a good direction for how we manage those materials. But that could vary from how often we cycle count them, how often we audit to make sure we have what we think we have. It can impact what we put on an auto reorder or what we're going to manually review. You know, when a reorder is triggered, it can affect a lot of things, but that ABC indicator is not necessarily a material criticality field. Okay, good. I was hoping for that. I'm making a claim there. Thank you. I didn't want to put you on the spot, but there are some EAM users in the world that would say, oh yeah, we've got a criticality indicator. Nope, it is not the same. It's not used the same. It doesn't have the same intent. Criticality, you know why I care? It's to determine what the appropriate service level is. You may have something that never moves. You know, it's very expensive, but maybe you never use it, but you need it, right? So that item might need a high availability. It might need by the way, let me set a little foundation here. You're going to hear me say A, B, C, D, and E. That's because that's just always the lens I've looked at materials, criticality-wise. A being the most critical, E being office supplies. It doesn't impact production or safety or the environment, right? So you're going to hear me say that, but that could easily be 1, 2, 3, or high, medium, low, you know, but I'm going to use A, B, C, D, E. So we're concerned with criticality to ensure we have the right stocking strategies. So if it is most critical, we need a high service level or a high availability, right? If it's least critical, we can accept some risk. We can accept the fact that it might not be there every time you need it. Is that fair? Okay, good deal. So why criticality? Well, this is the reason right here. When we have stockouts, and you don't have stock out when you don't need the part. I mean, that's just common sense, right? It's when you need that part. And when do you need the part? Well, if it's planned and scheduled, yeah, you need the part, but you can anticipate and hopefully order it based on a known lead time. It's the reactive, it's the break fix, the corrective work that, you know, you don't anticipate. That's when you discover you don't have the material you need. It's in that moment of crisis. That's when it hurts. That's when production is down and they're tapping on your shoulder, asking you when you're going to be running. And I'm scrambling to find the part. So the right criticality is going to mitigate that risk. It's also going to show us where we have surplus, and surplus leads to all sorts of problems. I'll repeat the same quote for the new people. But inventory isn't an asset, though we keep it on our books as such. It's waste. Oh, I've got this. Hold on. It is waste. Oh, yeah, it's working capital that's not working. Right, there we go. And it's subject to deterioration, to shrinkage, to obsolescence. You know, so that's why we care. It's a margin sinkhole. And oftentimes, it depends on the industry, but I've seen, I don't know, are there any oil and gas people? Oh, very good, okay. I've seen in oil and gas where they get I'm going to use the wrong term, but I think a spear sheet. It's a spare parts list from engineering, and it says, these are all the spares, here's where you need to stock it, we've got a new asset. 5 years later, some of these companies, hopefully not yours, are still sitting on those same parts that they absolutely needed because engineering said, and they hadn't touched them in 5 years. You get the risk, right? You just threw away a ton of money, and at some point those parts are obsolete. They are being maintained or at least taking up space. In oil and gas, sometimes that space is being leased or rented. So there are costs, I mean true costs with keeping this excess on hand. So that's why we care. I'm preaching a little too much. That's why we care. We want to strike a balance between risk to operations. Again, I'll give a nod to environmental health and safety as well, but a risk to operations balance against the cost of keeping and holding and maintaining, hopefully, that inventory. You guys don't want to hear the car story again, so I'm trying to think of a new one, but I've been using that one for a while. I kind of like it. So that's why, right, is striking a balance between cost and risk. So MRO, material criticality. Just a quick show of hands. I realize again that not all roles in this room, it's not going to apply to all the roles in this room, but does anybody that is familiar with their inventory at their site have criticality in place today for their materials? And I won't put you on the spot to ask for clarification. Okay, very good. So the next question, I'm not going to have you answer, but the next question is often, is it trusted? I'm not even going to look because it's a loaded question, but is it trusted? And then just like a stocking policy, so I add this bearing to the storeroom, set them in max, and I don't revisit it. Typically, is what I see across industries, all industries. It's typically not reviewed until a stock out occurs, and then there's an emotional reaction to increase the stocking levels. Not a mathematical approach, it's an emotional approach, typically. I know that's not all the time. Criticality, that when I've seen people that have it in place, it's often the same thing. They added this part, maintenance, me, said it's critical, and it might be critical to this pump, but to the operation of that pump, but was the question asked, is that pump critical to operations, right? This might be a critical part. In that context, it might not. It might be critical to make it run, but that might have very minimal impact on operations. So you see where even when criticality is assessed at the material level, it's not always maintained. It's not always reevaluated. I venture to say it's rarely, if ever, reevaluated, which poses a problem. Because I might use this bearing in this sump pump in the boiler room today. Tomorrow, we might get a brand new asset out there in the production floor that's mission critical to provide for one of our biggest customers. And guess what? It might happen to use the same bearing we have in stock. Well, that's swell. I don't have to buy another part, right? But the where used just changed. The criticality of this part just changed, right? So unlike assets, parts and materials, their criticality is subject to change. And we're going to explore that a little bit more in just a minute. Those in the other class know or the other session, sorry, like a teacher. The other session know that I'm talking about like procurement logic, leveraging that for criticality. So we're going to explore that a little bit. So the typical approaches we see today are typically, and it could be an E form, but it's typically like a form. That's what the clipboard represents there, but some sort of form that you go through and you say, yeah, it's critical and here's why, or no, it's not and here's why. And then it's entered sometimes into the EAM and that's where it stops. Sometimes it's not even the misused ABC indicator, but it's the, there's a flag, and I don't know specifically if EAM uses that or not. I know we typically would want to leverage a user-defined field. But in some ERPs out there, yeah, it's safe to talk about ERPs, you'll see a checkbox. The problem with a checkbox, it being binary, it is also abuse, right? There's no granularity, there's no indication of why, it's just critical. And I see this time and again where somebody has, the example I use is 100,000 items. We have clients with millions of items. And 70% of them are flagged with that little checkbox, they're critical. Are we gonna stock 70,000 out of 100? We're gonna stock 70,000 items at 98% service level? We're throwing away a ton of money and resources if we're doing that. So that's the problem with binary. And then there are best to breed solutions. You know where I'm going with that one. So this is just sample logic just to get you thinking a little bit. Again, some of you have processes in place today for criticality, and that's great. Some of you may not, or some of you may not have even been exposed to typical processes. This is not meant to be all-inclusive. I couldn't fit that on a slide. It's just to tease the thoughts out, right? So you've got a part, an item, this bearing, and you're starting right there in the starting block. And maybe you say, well, is it an insurance spare, or is it some sort of environmental health and safety? I like to point at like a pressure safety valve. Like, I don't care where it's used in the plant. I don't care if you ever document it on a parts list or a bill of material, or I don't care if you ever issued it on a work order, right? I don't care. That mitigates risk, right? A rupture disc, a safety device, a relief device, it's critical. There are other materials, you know, my office supplies and things like that, and that are not critical, right? So there are material classes, so we can start with that. Does it pass or fail that rule? and say, yeah, okay, it is an insurance spare, it is a critical spare, something, it's A. Again, I'm doing the A through whatever. And then, okay, no, it's not. Well, is it a capital spare? Just another way of looking at something that might be, pretty close to an insurance spare. Typically $0 value and typically not really monitored much for min-maxes, but that's okay. Let's just pass on through. Now we get to, is it fast moving? Now that's relative, very relative. But if you have something that's moving very quickly, being, turnover pretty quickly, and it's very inexpensive, that's probably a consumable. If so, we don't need to treat it as acritical. Now there's a different school of thought here to say, well, if it's consumable, we use it every day, we have this high need, it's very important. Like, yeah, but it's typically sourced by a vendor that comes in and tops off our bins and gives us an invoice. It's typically, managed and handled differently. So the point is, it's low risk. Even if it's critical, it's low risk. So that's why we've got, okay, fast moving, very inexpensive is not critical. And then we say, okay, well, what if it doesn't pass any of that? Has it been put on a bill of material? Now that in and of itself is a rule. By virtue of somebody taking the effort of putting something on a bill of material, you're implying it's critical versus the item you didn't put on a bill of material. Does that make sense? Right, so we can leverage that logic and say if it's on a bill of material, it's more critical than the C item. Or if we can look through historical work orders and understand where that part has been issued, depending on a few factors, is there some criticality at the asset level? If not, then it really doesn't hold much water. But if it's been used or it's on a parts list or a bill of material or been historically issued to a critical asset, let's inherit that criticality. Those are good starting blocks. Again, this is not meant to be everything. It's just to get you thinking. Okay. Let's see, this one's actually not going to run an hour. So let me pause there in case there are any questions thus far. So what happens if it falls into a different category, like repairable? Two categories. Oh, gotcha. Typically, I've been looking at it as kind of a waterfall. Like if it hits this, it stops, So I guess if we took the waterfall kind of approach, I'd want to make sure the logic has the right, significance. If there are two, it's almost like a stocking strategy. Like if it's an acritical, like let's take a different approach. It's an acritical item. I issued it to that sump pump in the boiler room. Who cares? Did I say A? Sorry. It's a bearing. Forget criticality. Sorry. The sessions run together. It's a bad move. So this bearing is issued to that sump pump in the boiler room. It's not critical. We added the critical asset in production. It serves our number one customer. It's the same bearing, now it's critical. Where I'm going with that is, I want to inherit the highest risk. I think I would do the same here, is if it hits 2 or 3, which is the higher risk? And let's just default to that one. Yeah. Make sense? Thank you. Anybody else? Yes, sir. Is that the same for like when asset used to be a B level, and then it was changed to an A level? Yeah. And that's why we preach this continuous automated solution, because our solution can pick that up. Every week it's looking for new data. If the highest criticality of the asset that this part is used on was an A and now it's a B, the solution can pick that up and then recommend that criticality can drop on that part. We can stop stocking quite as much as we were. So yeah, same logic. Leveraging AI. Now, pause. Yeah, perfect. Okay. These two are just more like placeholders. So balancing your risk and your cost. You got excess tied up working capital. I think I've hammered this home enough. And then the risk of stockouts. It's about finding that right risk. And then the probability and the impact. So remember, except for the 5 new people, remember the fuel line on the car, right? For those that weren't here, I had a real world scenario where a fuel line failed in a car, and I was able to replace it in a couple hours for very little money on my own in my driveway. My wife's fuel line took 6 months, custom order from Germany. Anybody would look at those assets, the cars that we rely on to get to work, the hospital, whatever, and say that they're critical, they're mission critical, we need them. We have an inline spare. I've got her car, she's got mine, right? So there is some risk mitigation, but nobody, I think, would argue that that fuel line isn't equally critical in both cars. The problem is balancing the risk, the likelihood, and then we're going to align that with procurement. So when we talk about long lead time items, hard, difficult to source items, there are a few other things. Higher variability in lead time. We start balancing all those things to understand risk and likelihood. I think the transmission would have been better there than the tire. So anyway, but this gets to the heart of it in my mind, where we really start to lean into the AI to unlock it, because that rule set I had with the process flow, start here, go here, right? We can automate that. That's business logic. You can say, okay, relief devices are critical. Office supplies are not. Let's look at where parts are used. Are there any EHS indicators on the item? So that's business logic. We can apply that and let that run every time you add a new part, or just run routinely every week in case something has changed, right? This is not just simply business logic, where you punch in some algorithms and say, here's the output I want. This is different. This is the material graph. So our large language model has been tuned on 50+ million unique SKUs. It's been trained for over 8 years, specifically again on MRO, and 9 billion transactions. I think it says 9 billion. Oh, it doesn't even say. Okay, yeah, but it's 9 billion plus transactions. So that's what you need for AI to be effective. Anybody use ChatGPT when it first came out and use it now? Not a lot of hands. Okay, well, that's fine. Massive changes, and all it took was time and tuning, right? Massive amounts of data. It's data hungry. So for a large language model to be effective, that's what you need. So we've got over 8 years of training this model. The graph database, anybody familiar with what graph databases do for us? Okay, a little bit, okay. So a traditional database with, you think of a table and another table, and they're related with a primary key, and that table has rows and columns. It's very effective for typical transactions. For AI, it's not effective at all. We need to understand that, well, here you go. We need to understand that a cylinder, yeah, let's use cylinder. Put it somewhere in a graph database, a vector database. It's assigned a number, a numeric value, right? And it's placed in space. Let's say right here. So that's a cylinder. And we might have a hammer or a bearing, right? And they occupy different spaces. We need a quick way of relating these things. So if I have this cylinder, another good example of something similar to a cylinder would be a sphere. It's not the same, but it's similar. So its numeric value is going to be a lot closer to that cylinder. Air does not equal pneumatic. Okay? Air powered equals pneumatic. You can train a large language model that they're not the same, but they are very similar. So their numeric value gets closer and closer together in this graph. So the more points of similarity, right, the more likelihood that this is the same or interchangeable or whatever. So when I go into EAM and I search air cylinder, no offense against AM, is it going to find pneumatic cylinder? Is it going to understand that I didn't put in the right thing, or that somebody put it in wrong in my catalog, right? If I search 3.25 inches, is it going to know that I actually mean 3 and 1/4 is, did I say 2.5? I hope I did. 3.25, does it know that I also meant 3, 1/4, right? These things, those things are exact, they're matches. Other things are very similar, air and pneumatic, right? So that large language model understands this. Now, if the whole use case was to say, well, you just identified a duplicate item in my catalog. Thank you, Verison. Kind of fell flat. There's value there, absolutely. A lot of value, frankly, and I could go into all those reasons why, but that's not the point. The point is, if I have a brand new 20 horsepower, 256T frame, AC motor, and I've got history, I've got bills of materials, I've got work orders, I've got procurement sources, and I know that, hey, by golly, in my plant, that's B critical, not A, but it's B. Now I have 50 other AC motors of varying horsepower, maybe similar frame styles, C-face versus whatever. They're all, can we leverage similar information to draw some conclusions? Right? It's not going to be a perfect fit necessarily for every item, but it is a heck of a good starting block to say the way that one plant consumes, uses, procures, and manages their 20 horsepower motor, I have nothing on mine, no history, very little usage or whatever, because maybe I just added it to stock. But the graph can expose that and say, hey, these are similar items. Can I leverage AI to say, hey, this is not a match, and let the machine learning understand that when I say it's not a match, this is not critical because of this reason, can it use that logic to look for other materials that are similar, present them to me and say, do you also feel that way about these materials, right? So you can start training the model to get smarter, to inherit certain business logic, maybe to reprioritize what classification makes it A or B. You can use AI to start leveraging those things. So there's a ton of insights that it'll unlock for you. Now, how are we doing? 30 minutes, okay. So, yeah, this one already built for me, I apologize there, but the idea, real simply, I keep using the example of 100,000 SKUs. 100,000 unique items in a catalog. Material classification alone is probably going to take care of, I'm just throwing numbers out there, but maybe 10 to 20% of those. The pressure safety valves versus the cleaning supplies versus the shop supplies, the things that we know that I don't care if they're on a bill of material or not, right? Because in the real world, when you go and audit a client's EAM or ERP, and you're looking at what percentage of those 100,000 items actually sit on a bill of material, depends on the industry, but I've seen that as few as like 2% of the items. There are some industries that are way more regulated, and that looks different, but it's never 50% of their items, I guarantee you that. So let's just pretend in some great universe that 50% of the items are on a bill of material. Let's leverage the asset criticality, or the asset type, or the asset functional location or function to be a starting point for the material criticality. That's a starting point, and that doesn't cover all the items. But remember the bottom 20% based on material class alone. Then there's this other 20, 30, 40, 50% of items that aren't on a bill of material. The classification isn't much help. But is there enough work order history to look at usage and to see where it's been issued via a work order to the right asset? That should start to fill in a lot of the blanks. I think we come up with about 82% coverage when we apply this kind of logic and systematic rules and classification. I think we come to about 82%. I don't know that it would ever be 100%. I don't know if that world exists. Some of those items probably need to be manually reviewed. So it's not perfect. But again, for those that weren't in the last session, that's the maintenance perspective, right? I'm looking at where they're used, are they on a bill of material, and I'm using that criticality for a starting point, but we're leveraging procurement logic to say, but that doesn't mean we treat everything the same. So the fuel line that I was able to get for my car in a couple of hours for very low cost, that's a procurement issue, right? How I sourced that, where I sourced it, what I paid, that's a procurement issue. My wife's car, with the one that took 6 months and $600 for her fuel line, procurement sourcing issue. It had to come from the OEM, it had to be made to order. So the reliability and maintenance perspective isn't enough when we're talking about increasing our profit margins to the right possible degree without jeopardizing uptime. We've got to leverage the other side of the house too, procurement and supply chain. Are there procurement and supply chain people kind of in the room? Are there any? Okay, very good, very good. Okay, hopefully I haven't offended anybody. And I think we start to align, right? Because they understand that, look, just because I say it's critical doesn't mean I need to stock 10. They understand the sourcing strategy and everything else, and maybe we can get away with squeezing the juice a little bit more. But then what I was trying to illustrate here is just kind of the machine learning, the user in the loop, where if you do disagree, that's fine. It recommends that it's, what was it, A? Yeah, it was A, it was downgraded because of procurement logic. Maybe the user has some tribal knowledge that we need to capture, and I disagree, and I keep it at an A. Maybe I'm talking to a new supplier and they aren't proven yet, right? Capture it. Can the model learn that, oh wait, if you captured it, and you captured the reason was because you were dealing with a new supplier, can the AI model look for other things where you're looking at a new supplier? Right? Are there other, I don't know if that's a good example, but are there other indicators that can be leveraged and learned from that action, from a user disagreeing, to train the model further? That's the food for thought, and I won't repeat this for the masses, but these are the kind of gains that you can get out of optimizing. It's directionally correct for most industries and most clients. I do see in oil and gas and mining, very asset-intensive industries where you're not stocking a bearing necessarily, you're stocking a whole generator set, right? Or you're not stocking a pump rebuild kit. You've got a whole triplex mud pump sitting over here, right? Very expensive, very large spares. So theirs is going to be directionally different. The other one is power generation and distribution, transmission. Theirs look a lot different. You're going to see a lot more inactive materials in those fields for good reasons. Storm spares, things of that nature. But general manufacturing, food and beverage, metals, not mining and metals, but metals, in a lot of other industries, this is pretty directionally correct. As a rule of thumb, as benchmarks, not a rule of thumb. One of the benchmarks is you're going to typically see a net of around 15% inventory reduction because you're bloated, you have too much. And I say net because the first thing we identify are those increases, the little red box there. Where are we at risk? And that's typically, it's either 5.1 or 5.9% of your inventory value that you're gonna have to spend that much more in stocking to offset risk. But it all ties back to the criticality and the desired service levels, or desired stocking levels. Okay, the more critical, the more you should carry, the less critical. That's why we want granularity to improve our cash flow as much as possible. The binary yes-no is not very effective. And really I think that's about it. I think the last slide was really just covering those AI models again, which most of you are already seen, that our system leverages. So I'm not gonna hammer that home. But I will just kind of give you a nice little summary here. Criticality is essential for effective MRO inventory optimization, understanding that criticality carries with it an associated service level or desired availability. Criticality in and of itself might be helpful reporting, but otherwise, who cares? Just give me the checkbox. If we're not using it for a desired service level or for desired availability, there's really not a lot of point other than reporting purposes. So leveraging criticality is that fundamental element for having the right stocking strategy, making sure we're not stocking out, but also that we're not carrying, I think of a lot of examples, but make sure that we're not carrying excess and surplus that's subject to deterioration and damage and shrinkage. Leverage AI to automate. Things are subject to change. Where used, right? We talked about that. The criticality logic, how parts are used, how they're procured. That's all subject to change. Business is not static, never has been. Nobody's running the same way today as they were last year or 5 years ago or 10 years ago. So with that in mind, team, I'm gonna give you a lot of time back.